Welcome to the introduction of the DID library, which enables you to work with decentralized identifiers across ecosystems and programming languages. Let's now have a look at what the main features are, so what you can do with the walt.id DID Lib. You can create DIDs based on different methods and key algorithms. You can anchor those in various digital identity trust registries, and you can resolve those DIDs from various digital identity trust registries to their DID documents. Our supported methods range from DID key, DID web, JWK, AppC, checked, IOTA, and many more using our integration of the Uni Resolver and Uni Registrar. Let's now see that whole thing in action. Here we are in a regular Kotlin project where I now imported the crypto lib as well as the DID lib to be able to work with decentralized identifiers. But the same thing could also be achieved in a Java project or soon a JavaScript project, as our libraries are multi-platform based using Kotlin multi-platform, which means they can be easily ported to other programming languages. Here I'm using as a first step the walt.id services, and we initialize that. That makes sure that our local registrars and resolvers are up to speed and we can use them to create decentralized identifiers. Because next to our local registrars and resolvers, we also implemented the DID Uni Registrar and Resolver, though we always recommend using our local one when we support the required DID methods. We did the implementation of the Uni Registrar to enable even more DID methods, as our local currently only supports DID key, DID web, DID JWK, DID AppC, DID checked, and DID IOTA. So for everything else, the Uni Registrar is a nice place to start, but you can also easily extend the DID library and write your own local registrar for your specific DID method. Let's now see how we can create our DID web. Here we use the DID web create options and then provide our domain, an optional path, and then the key type, which should be used to generate the DID of. In this case, it will use the ED25519 algorithm, but we can also, let's see here, can easily change that to use another. So then we take our DID service and register the DID web, providing the web options. And if we execute this, we will see that we get back our DID document, which we then could store now on our server, so walt.id, at this domain, to make it available to the public. Here in this example, I'm now using not our local resolvers, but the Uni Registrar and Resolver. So I also here again provide the DID key create options. In this case, it will be just a DID key using the ED25519 algorithm, and then I provide that to the registrar. And as you can see, it's the same call we also did here with our DID web, where we used our local registrar. But now here in the background, it will just use the Uni Registrar, which is really nice because you can start off with the Uni Registrar, for example, then build a local resolver and swap it out in the background, and you won't notice anything from that in the front end interface. So here you can also execute it and see that it actually calls the Uni Registrar and then responds with our DID key. The great thing is when you use the walt.id DID library that you by default get a support of multiple ecosystems in one place, from key, web, JWK, AppC, IOTA, checked, and many more when you're using our connection with the Uni Registrar and resolvers. As our project is multi-language based, you can work with DIDs natively in Kotlin Java and also soon JavaScript. Also regarding the storage options, we don't make any pre-assumptions, so you're super flexible when it comes to cryptographic key material storage as well as the DIDs. We here offer with the walt.id enterprise license various implementations with common KMS providers such as Vault, Oracle, AWS, and more. And as our project is open source under the Apache 2 license, you can easily extend it with your own custom functionality as needed and build on top of our modular system. So now it's your turn. Get started working with DIDs using the walt.id DID Lib. Click the link in the description to get started right away. Make sure to hit the like button if you enjoyed this video. And with that, happy building and see you next time.